This is SekharTech's first presentation. You can visit my blog at URL www.sekhartech.com. You can also email me at sekhartech2018@gmail.com. Today I am going to talk about the public key infrastructure, or the PKI, which is security of information, encryption, decryption, the hashing algorithm, the digital signature, and how they help to secure information. In the following slides, we will have an overview of public key cryptography, need for PKI, the components of PKI, and the applications of PKI. While doing electronic transactions, we face many security concerns. For example, privacy, authenticity, integrity, non-repudiation. Now, privacy means to keep information secret from all those who are not authorized to see it. Authenticity, proving the identity of an entity. It may be a person, a computer, for what it claims to be. Integrity, that is ensuring information has not been altered by any unauthorized means. And the next is non-repudiation, that is preventing the denial of previous commitments or actions. For example, a person may deny that a certain act has not been done by him when he has actually done it. PKI is also used to see that legitimate users have access to the data and they are available to them when they need it. It also keeps the unauthorized users away. Now we'll have a look on how the above concerns are mitigated in manual mode and electronic mode. In the manual mode, for maintaining privacy of information, like sending a confidential document to someone, we use an envelope, whereas in the electronic mode we use data encryption. For authenticity of a document, in the manual mode we get a document notarized or by physical presence. In the electronic mode we use a digital signature certificate. To check the integrity of a physical document, watermarks and barcodes are used, whereas in the electronic mode message digest and digital signatures are used. Non-repudiation can be overcome by taking signatures, receipts, or acknowledgements. The electronic system uses digital signatures and audit logs. Now, I am going to talk about cryptography. Cryptography is derived from Greek word cryptos logos, meaning hidden word. In simple words, it is secret writing. It enciphers a message using secret codes. Cryptanalysis, on the other hand, is the decryption and analysis of codes, ciphers built inside the encrypted message. A key is used to encrypt data. Basically, key is a large number which is used to encrypt data. To understand encryption, say each alphabet is shifted forward by 3 positions. Then the word hello becomes core. Decryption, on the other hand, is getting the original message using a key. Say, for the earlier encrypted message, the decryption key will be to shift each alphabet backward by 3 positions. Thus, core will become hello. Hash algorithm is used for verifying the integrity of a message. That is, whether any changes has happened during transfer of message or data. It produces unique fingerprint of the given message. No two different messages produce same digest. Similar messages always produce same digest and produces fixed length output. Input message can be of indefinite length and it does not involve any key. Computation of digest from message is easy and the reverse is not practical. That is, it is a one-way function. Usually, the hash function produces a 128-bit or 160-bit digest, which is known as a fingerprint. It is infeasible to produce a document which matches a digest. A 1-bit change in the message affects about half the bits in the digest. Suppose A wants to send a message to B and he wants that the message has not been altered. The mechanism is to pass the message through a hash-l function to form a digest and then it is sent to B along with the message. At B's end, the message is sent through the hash function to form a digest again. If the earlier digest is same as the new digest, the message has not been altered. The techniques used for cryptography can be of two types. One is symmetric cryptography, private key, and the other is asymmetric cryptography or as the public key. In symmetric cryptography, a single key is used and the same key is used for encryption and decryption. The advantage of symmetric cryptography is that it is less expensive. The disadvantages are key exchange in large environments and the number of keys to be maintained. In asymmetric or public key cryptography, two pairs of keys are used. One is the owner, which is known as the private key, and the other is the public key, which is made available to others. It is impossible to create one key from the other. That is, from the private key, you cannot derive the public key. I will now talk about how public key cryptography works. Suppose a sender A wants to send a message to B which B can only see. That is, A is the sender and B is the receiver. Here, A sends the encrypted text to B using B's public key. B receives the encrypted message and decrypts it with his private key. Here, B can only see. Privacy is established through the use of digital signature. In the case when A wants to send a message which anyone can see, it has to encrypt the message with his private key and anyone can decrypt using A's public key. Here also, privacy is established through the use of digital signature. For checking the integrity and mitigate the risk of non-repudiation, the following process is followed. The originator sends a clear text and generates a message digest and sends the encrypted text using his private key along with his digital signature. The receiver decrypts the text using the originator's public key and creates a message digest. If the originator's and recipient's digest matches, then it means no alteration of text has happened midway. Now coming to digital signature, let us understand what a digital signature is and what does it perform. It is a mechanism to sign electronic documents electronically. Analogically equivalent to the hand signature in the real world. It is message and signer dependent, used for integrity, non-repudiation and source authentication of electronic transactions and communications. A digital signature can be attached to the sender's document to form a signed document. The electronic document is fed into a one-way hash algorithm SHA-1 to produce a fixed length hash value. The hash value is a fixed number that is extremely sensitive to any changes in the document. Even a single bit change will result in a different hash value. The resulting hash value is next fed into the digital signature algorithm using the signer's private key to get the signed document. Now, for validating the digital signature, the signature is fed into the digital signature algorithm using the public key of the signer and producing what should be the same hash value. The public key cryptography is used in digital signatures and it is convenient to use. The disadvantage is that it is computationally intensive, 100 to 1000 times lower than symmetric crypto. The requirements in PKC is that the private key should be secure, that is, to be known to the owner only. Everyone should have access to the public key. The digital signature is provided by a certifying authority. The credential ties a name or identity to a public key. It has some specific attributes, including an expiration date. This is how a certificate looks in your computer. Now, I shall elaborate the PKI. PKI is a set of hardware, software, people, policies and procedures needed to create, manage, store, distribute and revoke certificates based on public key cryptography. PKI is an important tool for authentication and authorization, ideally suited to the needs of distributed computing. It is used in electronic commerce, communications on internet by SSL or the secure socket layer, ACT or secure electronic transactions, S-MIME or secured multipurpose internet mail extension. The PKI consists of policies and practice statements, the registration authority, repositories, and the certificate authority. Internal external clients, including browsers, secure mail clients, web servers, networks and applications, also uses the PKI. The certification authority is trusted by one or more users to create and assign certificates as per its policy and practice statement. It guarantees the connections between a key and an end entity. It establishes security domains. Now let us see how a certification process takes place. A person has to apply for a digital signature to a certification authority. The authority verifies the identity and approves request. The authority applies policies and procedures. A KPI is generated along with the digital signature with the CS digital signature and is given to the applicant in a smart card or a secure device. The CA keeps the certificate in a directory known as CRL or Certification Revocation List. A certification revocation list is a list of subscribers paired with certificate status where each end user's certificate is listed as valid, revoked or expired. A paperless office uses the PKI. It replaces handwritten signatures with digital signatures. All memos and letters are digitally signed and published in electronic form. PKI is also used in issuing purchase orders and email. We cannot think of financial transactions without the use of PKI. Financial applications that could be benefit from digital signatures are electronic funds transfer, purchasing, billing, payments. Vendor-contractor proposals are signed electronically. Automated payment authorization also uses the PKI. PKI is also used in electronic filing, like filing of tax returns to government or requesting different types of services. It is also used for software protection, software integrity verification, virus protection. PKI is at the center of security. It is used in protocols like SSL, SMIME, IPsec. It is used in technologies like directories, databases, hardware crypto, smart cards. PKI is also needed in communications of payments, mail, web, VPNs. Applications also uses the PKI, like the EDI education banking, e-commerce, digital signing, ERP. Thank you for watching this presentation.